The Hydra-Centaurus supercluster is the massive heart of the Laniakea supercluster. It is particularly significant because it contains the Great Attractor, the mysterious gravitational center that dictates the motion of over 100,000 galaxies, including our own. Structurally, it is divided into two major regions connected by a bridge of galaxies and dark matter. One, the Centaurus supercluster. This is the more dominant half of the structure. It is anchored by two massive galaxy clusters that exert incredible gravitational force. The Centaurus cluster, Abel 3526, a dense cluster containing hundreds of galaxies. The Norma cluster, Abel 3627. This cluster is located at the very core of the Great Attractor. Because it lies behind the zone of avoidance, the dusty disk of our own Milky Way, it was difficult to study until X-ray and radio astronomy allowed us to look through the cosmic dust. 2. The Hydra supercluster. Connected to Centaurus by a long filament of galaxies, the Hydra region is primarily dominated by the Hydra cluster, Abel 1060, a large cluster located about 158 million light-years away. It serves as a gateway between our local neighborhood and the even more massive structures deeper in the Laniakea complex. Technical profile. The sheer scale of this region is difficult to visualize, but here is how it compares to our own neighborhood. Feature, details, distance from Earth, approximately 150 to 200 million light-years. Primary motion. Galaxies in this region are moving toward the Shapley supercluster. Key members: Centaurus cluster, Hydra cluster, Norma cluster, and Antlia cluster. Significance. It acts as the gravitational drain for the local group. The Great Attractor phenomenon. The Hydra-Centaurus supercluster is the reason the Milky Way isn't just sitting still. We are being pulled toward this region at roughly 600 kilometers per second. For decades, astronomers couldn't explain why everything was moving in that direction. We now know that the combined mass of the Hydra-Centaurus supercluster, equivalent to tens of thousands of Milky Ways, creates a gravity well so deep that it influences cosmic flow across a region 500 million light-years wide. Relationship to the Shapley supercluster. While Hydra-Centaurus is powerful, it isn't the final destination. Observations suggest that the Hydra-Centaurus supercluster itself is being pulled toward the Shapley supercluster, an even larger megastructure located further away. This suggests that Laniakea is just one part of an endless chain of falling matter in the cosmic web. The Laniakea supercluster is our home in the cosmos, a massive structure defined not just by the location of galaxies, but by their gravitational flow. It is essentially a watershed of space, where all galaxies within its boundaries are moving toward a common gravitational center. Laniakea is composed of several major components that were previously considered independent superclusters. Major member superclusters. Under the modern definition established in 2014, these distinct regions are now recognized as lobes or arms of the greater Laniakea structure. 1. Virgo supercluster, the local supercluster. This is our immediate neighborhood. It contains the local group, the Milky Way and Andromeda, and is dominated by the massive Virgo cluster. While it was once thought to be a standalone supercluster, it is actually just one appendage of Laniakea. 2. Hydra-Centaurus supercluster, located near the heart of Laniakea. This region contains some of the most massive concentrations of matter in our vicinity. It is divided into two main parts: Hydra supercluster, also known as the Antlia Wall. Centaurus supercluster, home to the massive Centaurus cluster. 3. Pavo Indus supercluster. This is a long filamentary extension that stretches away from the central region, forming one of the prominent tails of the Laniakea structure. 4. Southern supercluster. This component includes the Fornax cluster, the Eridanus cloud, and the Dorado grouping. It represents the lower portion of the Laniakea flow. The Great Attractor, the cosmic center. The defining feature of Laniakea is the Great Attractor. This is a gravitational anomaly located in the vicinity of the Norma cluster. It acts like the bottom of a bowl, pulling all the member superclusters listed above toward it at hundreds of kilometers per second. Key structural facts. Feature. Details. Diameter, approximately 520 million light-years. Mass, roughly 10 to the power of 17 solar masses. Galaxy count, over 100,000 galaxies. Boundary, defined by the divergence point, where galaxy motion shifts toward a different supercluster, like the Shapley supercluster. Cosmic context. Laniakea itself is part of an even larger structure called the Pisces-Cetus supercluster complex, a galaxy filament that spans about 1 billion light-years. While Laniakea feels immense, it is just one basin of attraction in the vast, web-like architecture of the observable universe.